today, I'm Dr. T and welcome to my dining room. So today I'd like to look at a classic dilution problem. So when we've got this one, we're going to be making a dilute solution of hydrochloric acid from concentrated hydrochloric acid. Most of your stock acids are actually sold in their concentrated form. It's easy for the manufacturers to make. Just take hydrochloric acid and bubble it through water until it won't dissolve anymore. And boom, you have concentrated hydrochloric acid, which is roughly 12 molar. You actually get a couple of versions, so it can change a bit. So that's why we're only doing 2 sig figs here. But we got 2 sig figs, this will work. Okay, so we're taking concentration of hydrochloric acid, removing the hair from the screen. That is 12 molar, and we're going to dilute this down to 0.1 molar. We want to know, well, how much hydrochloric acid of the concentrated variety do we need? So this is a classic M1V1 equals M2V2 equation. Alternatively, the M's could be C's. M stands for molarity, C stands for concentration, whichever you prefer. Okay, so if we were to think about how we would do this, is we would take ourselves a volumetric flask, we would have water in here, and then we would add some of the concentrated HCl to that, and then we would add some more water to it. You don't want to just take the concentrate and dump the water straight on there. That'll get a little bit too hot, a little bit way too quick. And then we'll fill this to a mark. Now, the final volume that we fill this up to, that's going to be V2. So when I've got this, I'm going to plug in my 1 liter there. Now, the concentration that we're finally done with, that's going to be M2. The concentration of the HCl that's going on there, that's M1. And the volume that's transferring in, that's V1. Notice how the H2O, that's not part of the equation. The volume of water we're using to dilute it, not a deal. And of course, you can do this if you don't have water. You know, this is the particular case study, but you know, I can dilute random thing with random solvent. You know. Okay, so basically, I'm just going to plug and jug. Let's take this one. I've got 12 molar times, I don't know, that's what I want to know, equals 0.10 molar times, and so here's kind of a choice I go. I can put in liters there and I'm going to get my answer out in liters. But odds are I actually want my answer in milliliters. It doesn't say, so you can do whatever you want, so it just says volume. But I'm going to put in milliliters here. So I'm going to say 1,000 milliliters. That way, you know, it's more practical. The graduated cylinder is going to be listed in milliliters, and we're probably talking, you know, a few milliliters here. Okay, so yeah, time to start moving numbers around. I'm going to take this side, divide by 12 molar. Divide by 12 molar, the molarity cancels. This is why you can use whatever units you want. They're going to cancel. So I grab my calculating device, and I'm going to take 0.1 times 1,000 divided by 12. That gives me 8 1/3. So this is going to equal 8.3 milliliters is my V1. So I make that, see if I can draw my box, I put in 8.3 milliliters of concentrated hydrochloric acid in there. So yeah, pretty straightforward. So with that said, I'll see you in later videos. Have a wonderful day.